In this video, we will analyze the relationship between displacement, velocity, and acceleration. We will look at an object moving at constant acceleration. Let's assume the constant acceleration is 2 meters per second squared. Under the acceleration column, we will put the values 2 because the acceleration does not change. Now, an acceleration of 2 meters per second squared refers to the fact that the velocity is increasing at 2 meters per second. So in 1 second, the velocity change is 2 meters per second. Now, the object is initially at rest, as seen from the velocity of 0 at the start. So between 0 to 1 second, the change in velocity is 2 meters per second, and therefore, in the first second, the velocity should be 2 meters per second. Now, from the first second to the next, the velocity will also change by 2 meters per second, and therefore, the velocity of the object at the second will be 4 meters per second. We can see that there's a pattern establishing, and we can deduce that in the third and fourth second, the velocity will reach 6 and 8. Okay, what we see here is a uniform increase in the velocity. So the velocity is increasing, the object is moving faster and faster, and the increase in the velocity is at a constant rate. In order for us to find out the displacement of the object, we will need to look at the velocity time graph. This is what the velocity time graph of the object will look like. In the first second, in order for us to calculate the displacement, we need to look at the area under the graph. So the area under the graph is depicted by the blue triangle, and the area of this triangle will be half times 1 times 2, which gives us a displacement of 1 meters. So I'll key in the value 1 meter here. Now in the next second, the area expands and is depicted by the blue triangle now. If we calculate the area of this triangle, we will find that the area under graph will be equals to 4 meters, and therefore the object would have moved 4 meters from its original position. Now, subsequently in the third second, the area under graph would be 9 meters. And subsequently, we can see that this area under the triangle will be 16 meters. Okay, we notice a trend that the displacement is not increasing at a particular pattern. In fact, the displacement is actually increasing at an increasing rate. And this is due to the fact that the change in velocity is actually increasing.